Hello guys, welcome to Maths by Bodania sir. In this video, we are going to solve 5 very important questions from the chapter Surface Area and Volumes for class 10th board exams. I will explain the concepts and solutions step by step. Don't forget to subscribe and press the bell icon to get updates on all types of questions, be it MCQs, case study, assessment region, and descriptive 2, 3, and 5 marks. Pause the video, try the question yourself, and then watch the solution. Let's start. In question, it is saying in figure from a cuboidal solid metallic block of dimensions 15 centimeter into 10 centimeter into 5 centimeter, a cylindrical hole of diameter 7 centimeter is drilled out. Find the surface area of the remaining block. Use pi is equals to 22 by 7. Okay, now what we have to do is we have to find the total surface area of the figure that we have obtained after drilling out the cylindrical hole. Now, to find this total surface area, what we can do is first we find the total surface area of this cuboidal block. Next, what we will do, we will remove this upper part and this lower part of this cylindrical block area, because this is hollow, so we have to remove this area from the total surface area of solid metallic block. Next, what we have to do is we have to add this curved surface area of this cylindrical hole. So now we can say that surface area of the remaining block, that will be equals to total surface area of cuboid minus 2 times area of circle with 7 centimeter diameter plus CSA of cylinder. So let's find all of these one by one. TSA of cuboid, that will be equals to 2 times of LP plus BH plus HL. Now that is equals to 2 times of L, length is 15 into breadth is 10 plus B is 10 into H is 5 plus H is 5 into L is 15. So from here we will get 150 plus 50 plus 75, that is equals to 2 into 150 plus 50, 200, 275, that is equals to 550 centimeter square. Next, what we have to find is 2 times area of circle. Which circle? Upper and lower face of this cylinder, because this is hollow cylinder. Okay, so 2 times of area of circle, that is equals to 2 into pi r square. Diameter is 7, so r is 7 by 2 whole square. From here we will get 2 into 22 by 7 into 7 by 2 into 7 by 2. 7 to 7 cut into cut 11, that is equals to 77 centimeter square. Now third, what we have to find is CSA of cylinder. So CSA of cylinder, that is equals to 2 pi r into h, that will be equals to 2 into pi is 22 by 7 into r is 7 by 2 into h. Height is, now here height of this cylinder is equals to height of this cuboid, so the height will be 5. So from here we can say this is 110 centimeter square. So now we have found all the three values, so we will put the values and find the answer. So from here we can write, therefore required surface area, that is equals to TSA of cuboid is 550 minus 2 times area of circle, that is 77 plus 110, that is equals to 583 centimeter square. This is the answer. Clear? Question number 2 is saying a solid cone of base 10 centimeter is cut into two parts through the midpoint of its height by a plane parallel to its base. Find the ratio in the volumes of the volumes, okay, of the volumes of the two parts of the cone. Okay, now what we are given is we are given a cone with base radius 10 centimeter. Okay, let's say this is the cone and this is 10 centimeter. Okay, Now let's assume its height is h. Now it is saying that this cone is cut from the midpoint of its height. This height will be h by 2. Now what we have to find is to find a ratio of volume of this upper part, this lower part. This lower part is frustum. Basically frustum has been removed from your syllabus, but this question can actually come in exam because you don't need the frustum formulas to solve this question. Now what we have to find is we have to find radius of this upper cone. Let's say small r, and let's say this is capital R. So to find small r, what we can do is we can use BPT, basic proportionality theorem. Okay. Now we know that this cone has been cut parallel to base. So if this is h and this is h by 2, so what we can do is we can use BPT. As we know this is 10 centimeter and this is r. So using BPT we can say that h upon h by 2 will be equals to 10 upon r. So from here this 2 will go in numerator and h will cut h, that is equals to 10 by r. So r will be equals to 5 centimeter. So the radius of upper part of cone is 5 centimeter. Now we can easily find the ratio. Now what we have to find is volume of upper part upon lower part. Volume of lower part. That will be equals to volume of small cone upon volume of whole cone minus volume of small cone. If we remove the volume of small cone from the whole cone, then we will get the volume of this lower part. Okay. So from here we can write volume of small cone, that is 1 by 3 pi r square h by 2 upon 1 by 3 pi. Now volume of whole cone, then this is capital R square into h minus volume of small cone, that is 1 by 3 pi small r square into h by 2. So from numerator and denominator we will take common, that is 1 by 3 pi h. So in numerator we will get r square by 2 upon, from here 1 by 3 pi h, we will get r is capital R square minus small r square by 2. So on cutting this we will be remaining with small r square by 2 upon capital R square minus small r square by 2. So from here we will put the value small r is 25 by 2 upon capital R square, that is 100 minus 25 by 2. On solving further we will get, taking LCM, we will get 200 minus 25, that is equals to 25. So this 2 will cut this 2, 25 upon 175, so that is 1 by 7. So from here we can write, therefore required ratio is 1:7. This is the answer. Clear? Okay. Now question number 3 is saying the dimensions of a solid iron cuboid are 4.4 meter into 2.6 meter into 1 meter. It is melted and recast into a hollow cylindrical pipe of 30 centimeter inner radius and thickness 5 centimeter. Find the length of the pipe. Okay. Now here what we are doing is we are transforming the volume from one figure to another figure. So the volume of both the figures should be equal. So now what we have to do is we have to change this figure from cuboid to hollow cylinder of the required measurement. So we are given that inner radius is 30 centimeter and thickness is 5 centimeter. So let's say this is the figure. Okay. So we are given that this radius r, this is 30 centimeter and thickness is 5 centimeter. So from here let's say outer radius will be equals to small r plus thickness, that is 30 plus 5, that is equals to 35 centimeter, and the small r, that is inner radius, that is 30 centimeter. Okay, and we are given the dimensions of this cuboid, that is 4.4 meter, breadth is 2.6 meter, and height is 1 meter. Okay, now volume of cuboid should be equals to volume of hollow cylinder. So from here, volume of cuboid, that will be LBH, that is LBH, that is equals to volume of hollow cylinder. So volume of hollow cylinder will be equals to pi capital R square minus small r square into H. Now the dimensions of cuboid are in meter and dimensions of hollow cylinder are in centimeters. So let's change dimensions of cuboid in centimeter. So length will be 440 centimeter, breadth will be 260 centimeter, and height will be 100 centimeter. So from here we will write 440 into 260 into 100 equals to 22 by 7 into 35 square minus 30 square into H. H is what we have to find. Let's the height of this cylinder be H. Okay. So from here we will write H is equals to 440 into 1260 into 100 upon 22 upon 7 will go in numerator upon 35 square minus 30 square. So here we will use a square minus b square. So this will be a plus b, 35 plus 30, a minus b, that is 35 minus 30. So from here, cutting this, we will get 20, and 20 into 260 into 100 into 7. In denominator, we will get 65 into 5. So from here, we will cut this. 13 5 is 65. 13 2 is 26. 5 4 is 20. 5 4 is 20. 4 4 is 16 into 7, 112 centimeter, or 112 meter. So therefore length of the pipe, that is equals to 112 meter. This is the answer. Clear? Now in question number 4, it is saying water is flowing at the rate of 15 kilometer per hour through a pipe of diameter 14 centimeter into a cuboidal pond which is 50-meter long and 44-meter wide. In what time will the level of water in the pond rise by 21 centimeter? What it is saying is, let's say this is the cylindrical pipe through which water is flowing at the rate 15 kilometer per hour. Okay, what does it mean by 15 kilometer per hour? Means if the water is flowing through this pipe, then the volume of water flowing out of this pipe will be equal to the volume of this cylinder of height 15 kilometer, that is 15,000 meter, and the radius of this pipe is given, that is diameter is 14, then radius will be 7 centimeter. So in 1 hour this much of water will flow out of this pipe, that is equals to volume of this cylinder. And what it is saying is this water is flowing in a pond that is 50-meter long, 44-meter wide, and it is saying how much time it will take so that the water in the pond rises 21 centimeter. So what we have to do is, let's say let time taken be t hours. So in T hours, the volume of water flown out of this pipe will be equals to the volume of cuboidal pond with the height 21 centimeter. So from here, we will say volume of water flown out of the pipe into T, that is R, that will be equals to volume of cuboidal pond with height 21 centimeter. Now volume of water flown out of the pipe in time t, that is equals to, in 1 hour the volume will be volume of this cylinder, that is pi r square into h, pi r square into h into t, volume of cuboidal pond, that is lbh. So from here we can write 22 by 7 into, so r is in centimeters, so we have to change it into meter, so it will be 7 by 100 square into h is 15,000 into T equals to LBH. L is 50 into 44 into H is 21 centimeter. Again, we have to change it into meters, that is upon 100. So from here, T is equals to 50 into 44 into 21 upon 100. And from the left hand side, this 7 and 100 into 100 will go into the numerator. That is equals to 7 into 100 into 100 upon 22 into 7 into 7 into 15,000. Okay, so from here we can cut this two times. This 7 will cut this 100 will cut this, and these three zeros will be cut by these three zeros. And from here 7 will be cut by 7 three times, and what 5 3 ja and 3 3 ja, that is 2 hours. So from here we will write, therefore in 2 hours level of water in the pond rise by 21 centimeter. This is the answer. Clear? Okay. Next question number 5 is saying a well of diameter 4 meter is dug 20 meters deep. The earth taken out of it has been spread evenly all around it in the shape of circular ring of width 3 meters to form an embankment. Find the height of the embankment. Okay. So what it is saying is a well has been dug. Let's say this is the well. Okay. And the earth taken out of this well is spread across, let's say this is the earth surface. Okay. Now what it is saying is the earth taken out of this well is spread across this well to form an embankment of thickness or width 3 meters. So let's say this is the inner radius small r, and this is the outer radius capital R. So small r, we know the diameter of well, that is 4 meters. So r small r will be equals to 2 meters, and capital R will be equals to the width of this circular ring is 3 meters. So capital R will be 2 plus 3, that is 5 meters. Okay. Now outside this well we will get a hollow cylinder like this. Okay, and this is the well below the earth. So what we have to find is we have to find the height of this embankment. Okay, so what we will do, because the volume of this earth taken out and deposited around it will be equal, so we will be equating those two volumes. And we are also given that the height of this well is, that is 21 meter. Okay, and let's say the height of embankment be small h, so what we have to find is small h. So from here we can write volume of earth taken out will be equals to volume of hollow cylindrical embankment. So volume of earth taken out, that is volume of this cylinder, this well, that is equals to pi r square, that is small r square into capital H, that is equals to volume of this hollow cylinder, that is embankment, that is equals to pi capital R square minus small r square into small h. So from here pi will cut this pi, and small r, we know the value of small r is, that is 2 square into height is 21, that is equals to capital R square, that is 5 square minus small r square, that's 2 square into h, small h. From here we will get the h, that is 4 into 21, 5 5 is 25 minus 4, that is 21. 21 will cut 21, that is equals to 4 meters. So from here we can write, therefore height of the embankment is 4 meters. This is the answer. Okay, here we end the video. If you like the video, hit the like button, share this video with your friends so that they can also get benefited. See you in the next video. Bye bye.